I'm Dave Brown, a volunteer and president of the Vintage Tech Museum. This birthday poster was from the Tektronix 40th anniversary celebration in 1986. It's a photo of a clay sculpture created by Will Vinton Studios in Portland. The museum has the original clay sculpture on display. This tour of 75 exhibits is to commemorate the 75th anniversary of Tektronix, founded in 1946. With 75 exhibits, we're going to be brief with our comments, but more information on each of the exhibits is on our website. We hope you enjoy the tour. The museum was founded by ex-Tech employees Stan Griffiths and Ed Sinclair in 2011. We are located on the Tektronix campus in Beaverton. Our focus is to encourage the next generation of engineers through the museum and supporting STEM in our local community. The museum and website is dedicated to displaying working Tektronix products which enabled generations of scientists, engineers, and technicians to create the future, and to the memory of those employees that created this legacy. Our website is full-featured and contains over 80 of our exhibits, 75 historic films and videos, and hundreds of vintage photographs and promotional material, as well as printed documentation. Our museum was recognized by Electronic Products Magazine in 2018 as one of the top 10 electrical history museums in the U.S. to visit. As part of our support of STEM, we also have a lending library of Tektronix instruments for students 10 years and older. Jack Murdoch graduated from high school in 1935. His parents gave money to either enter college or start a business. Jack chose to start the M.J. Murdoch Company. Howard Vollum graduated from Reed College in 1936 and afterwards held a variety of jobs. Jack hired Howard to take care of his radio service department so that he could put full effort on sales. As the U.S. entered the war, Jack closed the store and enlisted in the Coast Guard. Howard was drafted into the Army. While in the Coast Guard, Jack met Miles Tippery. After the war, Jack, Howard, and Miles, along with Glenn McDowell, who was Jack's accountant, decided to start a company focused on the emerging electronics market. They formed TechRad on January 2, 1946, but a short while later changed the name to Tektronix on February 4th. Tektronix started in a couple of basements. Eventually Howard moved his bench to the M.J. Murdoch Company, but the Foster Road location soon became too crowded. The business relocated to 7th and Hawthorne in Portland and was known as Hawthorne Electronics. The upstairs became the new home of Tektronix in May of 1947. Howard Vollum was drafted and stationed at Camp Roberts in California. An officer who was an engineer with the Bonneville Power Administration took advantage of Howard's expertise by assigning him to fix radios on the base. Since Howard's skill was highly prized, he remained at Camp Roberts beyond his training period. Howard was promoted from corporal to second lieutenant and reassigned to Fort Monmouth in New Jersey. Fort Monmouth was headquarters for the Army Signal Corps and a collection point for hand-picked recruits for the radar training program in England. Howard was sent to England and trained on high-frequency radar. After training, he was assigned to a new radar fire control system to direct 15-inch guns on German ships. Howard's role was to develop the display, which appropriately enough was similar to an oscilloscope. After 2.5 years in England, Howard was reassigned to Camp Evans in New Jersey. There he worked on an advanced fire control system capable of tracking mortar shells with radar that could respond to remove the threat. On July 18, 1945, Howard was awarded the Legion of Merit for his work in England. Later he was awarded a second Legion of Merit for his work at Camp Evans. It is highly unusual for an individual to receive 2 Legion of Merit awards. Glenn McDowell chose to stay with Hawthorne Electronics. The 3 founders established their roles, with Howard doing product design, Jack handling the business, and Miles taking responsibility for operations. As they began to ramp up plans for production of the oscilloscope, Miles suggested they first build a less complex product to establish processes and gain some experience. Howard had designed a number of his own test equipment, so suggested his test generator. Tektronix's first product was the Type 101 video calibrator, which was simply a square wave generator. Tektronix produced 10 of the Type 101 instruments. You will note the unique serial number of 11461. This represents November 1946, number 1. This indeed is the actual first product manufactured by Tektronix. There wasn't a strong demand for a square wave generator, and none of the 10 instruments sold. While Tektronix's first product was not a success, it successfully paved the way for the manufacture of the Type 511 oscilloscope. The 511 oscilloscope first shipped in July of 1947. Tektronix didn't advertise the product initially. The April 1948 magazine Electronics simply referred to the instrument as a volumoscope. Tektronix's first ad for the 511 appeared in the September 1948 issue of Electronics. The 511 was a masterpiece of design. Howard knew firsthand what he wanted in a precision oscilloscope. The 511 was smaller, less expensive, and offered more functionality than its competitors. It enabled precision measurements of both time and voltage with an oscilloscope. The tiny upstairs of Hawthorne Electronics was now running 3 full shifts to manufacture the 511. Tektronix had a winner. It was obvious to the founders that they needed a new and larger facility. Our 511 oscilloscope is the 340th instrument produced. It is fully operational 70-plus years after manufacture. While the 511 was an immediate success, it did have a few deficiencies that needed to be addressed. It couldn't display the trigger portion of the signal, power supply lacked regulation, it did not function with signals below 60 Hz, and had insufficient vertical sensitivity for some applications. Later revisions of the 511 added a delay line to be able to view the trigger portion of the signal and the circuitry to regulate the power supply. Improving the bandwidth to DC was addressed for the follow-on product. The 511 had 2 stages of gain, which provided the maximum sensitivity of 250 millivolts per centimeter. To achieve greater vertical sensitivity, the 121 preamplifier was developed, which provided up to 100x gain and preserved the bandwidth of the oscilloscope. The 121 first appeared in the 1950 catalog for a price of $265 and last appeared in the 1959 catalog. Frank Hood was hired as employee number 32 in February 1949. The engineering department consisted of Howard Vollum, Logan Belleville, Bob Davis, Dick Rieger, and Frank Hood. From time to time, Frank brought his camera and filmed interesting operations around the plant. He was asked to record processes and instrument applications. Frank made a 30-minute film on his own called The Tektronix Spirit in the mid-1950s and showed it to employees, families, and friends. Requests to borrow Tektronix films came in from schools, government, and industry. It seemed that the free loan of films was bringing a lot of goodwill. In the early 1960s, Frank was asked to set up a film production and distribution department. He was left on his own as to the subject matter, the style of presentation, and even the intended audience. Most of his films were aimed at the technical student or person interested in technical matter. The film showed the use and application of Tektronix instruments, but seldom mentioned Tektronix except in the opening and closing titles. They were usually very low-key and contained no direct advertising. Visit our website to watch these historic films. Tektronix took photos of their employees. The earliest photo album we have at the museum is 1950 and is organized by department. As the company grew, the photo albums were no longer organized by department, but rather in somewhat chronological order with an index to be able to locate each employee. The last photo album produced was May of 1970 and contains 12,854 photos of employees. When visitors tour the museum, we asked if they or any relative ever worked for Tektronix. If they did prior to 1970, we will look up and give them a print of the photo of the employee. A number of our current volunteers are included in the album. We have scanned the May 1970 photo album and offer it for sale on a DVD at the museum's eBay store. Miles Tippery, one of the 4 founders, wrote an autobiography which included his years at Tektronix. We have published that portion of the autobiography dealing with Tektronix and sell it on our eBay store. It contains a lot of insight into the early days of the company. One of his mentions is that in late 1945 and early 1946, the founders thought there would be considerable merit in building custom electronic equipment for customers who needed only an instrument for some special application. They reasoned that it would be more efficient for a small company to do this work than for a large engineering and manufacturing company. Dr. Archie Tinteri of the University of Oregon Medical School was studying the electrical waves generated by the brain in response to different kinds of stimuli. This required many hundreds or thousands of separate tests to record this data, which was very time-consuming. Dr. Chinteri conferred with Howard Vollum, and together they designed an oscilloscope which could display 50 different waveforms simultaneously and be photographed on one negative. The Type 512 oscilloscope added some features missing from the 511, specifically increasing the vertical gain and incorporating DC coupling to extend the frequency response to full DC. It was priced at $950 and announced in the December 1948 issues of Electronics and Proceedings of the Institute of Radio Engineers. The Type 512 was meant for biological work. It had a differential input amplifier, which could display signals as low as 1 millivolt and frequencies up to 2 megahertz. It had relatively slow sweep that was very linear. It was called the Phantasatron circuit because it was so fantastically linear. The designer of the 512 was Logan Belleville. It immediately became evident that the 512 was so sensitive that, at its highest sensitivity, the aging of the input tubes caused the trace to drift. Logan devised an aging process that would cycle the tubes 45 minutes on, 15 minutes off, for 24 hours to address this issue. The 512 last appeared in the August 1954 catalog. The Type 513 oscilloscope is a precision instrument intended for the study of short-duration pulses. The sweep dials facilitate easy measurement of duration. The 513 was first shown at the 1950 Institute of Radio Engineers meeting in New York City in March. It first appeared in the Tektronix June 1950 short-form catalog for $1,600. The designer of the 513 was Frank Hood. He wrote, "I was privileged to be the project engineer in designing the Type 513, a scope with about twice the bandwidth and brightness of the 511. This instrument used a distributed amplifier with 14 tubes in the output stage. These oscilloscopes were used in earlier nuclear research. Dozens of scopes were used to record an event that only lasted a fraction of a second. The 513 was first introduced with Dumont CRT, which was later replaced with the first Tektronix-made CRT, the T51. The T51 employed a pioneering resistive helical that gradually increased the acceleration potential to minimize deflection distortion. The Tektronix Type 514 was a general-purpose laboratory oscilloscope that improved upon the bandwidth and sensitivity of the 511 and 512. The 514 featured DC response with a full 10 MHz bandwidth and sensitivity of 30 millivolts per centimeter. In his memoirs, Frank Hood recalled the 514 was designed by Bob Davis and Dick Rieger. Bob Davis would later be head of manufacturing and Tektronix's first executive vice president. Dick Rieger would go on to design the revolutionary 517 high-performance oscilloscope. The 514 first appeared in the October 1950 catalog and sold for $900. Production started in the fall of 1950 with 4 employees. Early Tech Talks, the company newsletter, would feature departments and employees. A June 1952 issue mentions a total of 15 employees now in the 514 manufacturing group.
I'm Tom Goodapple, a volunteer who spent most of my career at Rogers Organ Company, an early tech spin-off funded by Howard Vollum himself due to his avid interest in organs. In June of 1949, Tektronix developed a wideband, high-speed oscilloscope under contract to the Air Materiel Command. This oscilloscope pushed the limits of high-speed analog design using distributed amplifiers. This research led to the development of the 517 oscilloscope, which achieved a performance of 50 megahertz. The 517 was designed by the first 3 Tektronix engineers, Howard Vollum, Logan Belleville, and Dick Rieger. The innovative design required many more amplifier tubes than a conventional oscilloscope, with a total of 130 vacuum tubes, and power consumption was 1,250 watts. Most 517s were mounted on the 500 series scope mobile, providing some amount of portability for the instrument. The 517 used the Dumont CRT in the first 825 instruments and Tektronix CRTs afterwards. The 517 and 517A enjoyed a 14-year production life until replaced by the 547. We believe the museum's oscilloscope is the only operational 517 in existence. Tektronix was bursting at the seams in the Hawthorne plant. They were running 3 full shifts. There was inadequate parking for employees, and they simply needed a larger facility. The choice was made to move west, but not far enough to be out of the local Bell telephone system coverage. The new location was the Sunset Plant near the intersection of Highway 26 and Barnes Road. The first groups moved into the facility in early 1951, but it was obvious by then that they needed even more room, so work progressed on expansion and adding new buildings. This photo shows the original building with 4 additions and the second building with 2 additions. Additional property was purchased to the east for expanded employee parking. The museum's website contains a number of additional photos, building layout, and employee photos. Even with this expansion, it became clear that the growth of Tektronix would require even more space. In 1956, only 5 years later, Tektronix purchased 313 acres in Beaverton. Tektronix continued to occupy the Sunset location until they exchanged the property for a new site on Walker Road, just 6 miles to the west. This lunchroom chair is from the Sunset plant and can be seen in many different Sunset photos. It is marked with the Tektronix logo on the rear. The Tektronix logo was affectionately known as the Tech Bug and appeared in the first advertisement for the 511 in 1948. The logo consists of a Tektronix round-face CRT overlaid by the oscilloscope screen, displaying a sine wave with the name Tektronix across the front. Tektronix CRTs had changed from round screens to rectangular screens, and in 1967 the Tech Bug was upgraded to show a rectangular CRT profile. The Tech Bug remained the company's logo until the early 1990s. Tektronix oscilloscopes used cathode ray tubes from Dumont and RCA. Both Dumont and RCA also produced oscilloscopes, so Tektronix was dependent upon its competitors for a critical component. Howard had suspected that the suppliers were shipping their, quote, seconds to Tektronix and made the decision in the early 1950s to design and manufacture their own CRTs. A CRT building was constructed on the Sunset plant, and the first oscilloscopes to use a Tektronix CRT were the 531, 535, and later 513s. We have a display case at the museum for a small collection of Tektronix cathode ray items consisting of CRTs, CRT components, and memorabilia. These span the history of CRT development and production at Tektronix from start to finish. There also is a storyboard with pictures documenting the CRT operation and some of its employees and products. In addition, we display a collection of Tektronix CRT patents. We have an historic film on our website, a precision CRT, which is worth watching. The first Tektronix oscilloscopes were produced before printed circuit boards were in use. Electronic products were constructed with point-to-point wiring between components and were tedious to fabricate, difficult to troubleshoot, and aesthetically displeasing. Tektronix used Bakelite postboards to mount components in the early oscilloscopes. Ted Goodfellow had a better idea, employing notched ceramic strips mounted in orderly rows. The notches contained a silver coating for soldering components. This approach made for a professional and orderly appearance when the covers were removed. The first use of ceramic strips was in the Type 315 oscilloscope in 1952. Ceramic strips continued to be used on some 7000 series instruments until the mid-1970s, and plugins until the early 1990s. Tektronix was designing and manufacturing their CRTs with purchased glass funnels. These were only available in a limited number of sizes, and tooling for new funnels was very expensive. The ceramic operation would prove very valuable when ceramic funnels were developed in an effort led by William Wilbanks in 1961. The first CRT with a ceramic funnel was the T5610, introduced in the 561A scope in 1962. We also have an historic film on our website, Building a Ceramic CRT, which is worth watching. Tektronix purchased 313 acres in Beaverton in 1956. This was farmland with little infrastructure in the surrounding area. The buildings were referred to by numbers. The first one to be constructed was Building 70 for a warehouse with some office space in 1957. New buildings were soon added, 19 for metals, 39 and 47 for assembly, and 45 for a cafeteria. Construction of buildings 13, 74, and 76 was started in 1959. Within 10 years, Tektronix had constructed 15 buildings, totaling over 1 million square feet. A total of 28 buildings were constructed on this site. The site looked more like a college campus than an industrial complex. In 1966, Tektronix received an award for beautification of Oregon from Governor Hatfield for the Beaverton campus. Building 13 is in the northeast corner of the property and was the ceramics operation. It is the home of Vintage Tech Museum. The Type 519 was introduced at Westcon in 1959 and was the fastest oscilloscope with an astounding 1 GHz bandwidth achieved by driving the distributed deflection plate system in the CRT directly with no vertical amplifier. It was used for extremely fast transient pulse analysis and nuclear research. As such, it came standard with a camera mount bezel. Often, a number of 519s would be connected together to capture different time portions of high-speed phenomena. For comparison, 1 GHz represents 1 billion cycles per second. At 1 GHz, one cycle completes in 1 nanosecond, or 1 billionth of a second. For comparison, light travels just under a foot in a nanosecond. The 519 remained Tektronix's only 1 GHz oscilloscope until replaced in 1979 by the 7104 oscilloscope. That's an impressive 20-year product life. Tektronix held a number of scope classes over the years, which were documented in Tech Talk and Tech Week newsletters. The first scope class was mentioned in a May 1952 Tech Talk article. Tektronix organized these classes for employees who wanted to design and build an oscilloscope for their personal use. We believe additional motivations for the class were to help enable new ideas, concepts, and circuits to be tried out and evaluated. It also helped identify resources in the company that could be better utilized in design engineering. There were other mentions of a scope class in 1953, 54, and 58. By the 1960s, the Tektronix education program ran a scope class where individuals would build their own oscilloscope from a standard set of plans. We believe this scope class oscilloscope is from the original 1952 class. Our restoration engineer, Phil Crosby, has been studying the instrument to document this remarkable one-of-a-kind instrument. Dick Ropiquet worked on medical instruments, which Tektronix developed for the University of Oregon Medical School. These instruments, which were intended for use in research on the nervous system, proved successful enough to become standard products. They were introduced as the 160 series in 1952 as a set of modular bolt-in instruments. They remained in production until 1970. The 160 series consisted of separate instrument modules with a common power supply. The 125 power supply would power a single module, while the 160A would power 6 modules. The modules consisted of 161 and 163 pulse generators, a 162 waveform generator, and a 360 indicator or display unit. In addition, the Type 122 preamplifier was often used, and a later version was in the 160 form factor. You can find examples on the web today where musicians are using some 160 series instruments as music synthesizers, since they have the appeal of vacuum tubes. The Type 3A5 amplifier and the Type 3B5 time-based plugins introduced in 1966 were very unique and ahead of their time. The plugins feature a seek mode where they automatically set the horizontal and vertical parameters for a correct display. Today, modern digital oscilloscopes call this feature AutoSet. The plugins also feature a direct display readout of the horizontal and vertical settings. These plugins also interface to a Type 263 programmer which has 6 presets. These presets enable different programmed oscilloscope settings to be made with the press of a button. These programmed settings could be used in applications such as different configurations in manufacturing test. These automatic plugins and external programmer were years ahead of the competition and brought significant new capability to the market. Tektronix wanted a way to quickly enter the scientific calculator business. They acquired Sintra in 1971, who had developed the Model 909 Scientist and Model 911 Statistician calculators. Tektronix made some minor refinements and rebranded them as Tektronix, which is shown on the left. These were not just simple calculators, but advanced scientific instruments. With optional memory, the 909 and 911 could perform calculations with 100 levels of nested parentheses. They were also accompanied by a complete family of peripherals, including plotters, card readers, printers, teletype interfaces, and aids for programming. On the right is the follow-on Tektronix-designed 21 and 31 calculators. These featured magnetic tape storage and used more modern LED displays. Besides advanced scientific calculations, people wrote programs for games. At the museum, we have a game tape for football and blackjack. The next generation of calculators evolved into the 4050 series of desktop graphic computers. Traditional analog oscilloscopes depended on a repeating signal to refresh the display. One-time or single-shot events were very difficult to see. Cameras were used to record the event, but it may have taken several attempts to record a usable image. What was needed was a way for the oscilloscope to record and display the one-time event. The storage CRT was developed by Dr. Andrew Hafe, working at the U.S. Naval Research Laboratory in 1947. In 1950, he joined Hughes Research and Development Laboratories to advance the development of the storage CRT. Bob Anderson joined Tektronix in 1959 from Hughes, where he worked in CRT manufacturing. Hughes had developed a Memotron storage CRT and introduced a storage oscilloscope. Their storage CRT was quite fragile and expensive due to low yields. Bob was motivated to develop a better storage CRT. Bob's design resulted in a high-performance CRT with good manufacturing yields. The resulting 564S storage oscilloscope was introduced in 1962 with impressive specifications, offering 10 MHz bandwidth, low cost, and dual plug-ins for a wide range of capabilities. It opened the door to 20 years of leading-edge storage instruments, including information display, which we will see next. Early computer users employed the 564 storage scope as a display. Several models, like the PDP-8, had analog outputs that could be connected in XY mode. Tektronix saw an opportunity and created the 11-inch 611 storage monitor. It proved a popular graphics display. The 4601 hard copy unit served for printing. The next step was the T4002 with keyboard and 611 display in one unit. The price in 1968 was $8,500 with a computer interface. The cost of memory alone to build a raster scan monochrome monitor with the same resolution in 1968 would have been about $100,000. Lower cost and more capable Tektronix graphic terminals followed, which took the industry by storm. Tektronix graphics became the de facto industry standard. Because of their popularity, terminals with larger screens were developed. The 19-inch 4014 was the most popular, with over 3 million pixels. Priced near $10,000, it was Tektronix's highest revenue-producing product. The 4016 shown here utilized a 25-inch screen and was popular for computer-aided design. Tech dominated the industry throughout the 1970s and 1980s. The storage CRT was displaced when semiconductor memory of sufficient size and low cost became available, making raster scan products affordable.